Determine whether B is a vector B here is in the column space of A. If it is, write B as a linear combination of the column vector of A. What that means, these are vector, if I call this column vector, V1 and V2 and V3 like that. I mean, so is it possible to write this is C1 V1 plus C2 V2 plus C3 V3? That's what it means. Okay. So this one is right A 1 3 2 negative 1 1 2 0 1 1, and then C1 C2 C3 will give me 1 1 0. That is the question. So is it possible to have those C exist? If they exist, then the system is consistent. Okay, consistent means solution exists. So now do Gaussian elimination, negative 1, 1, 2, 0, 1, 1, so 1, 1, 0. So this is obvious that you're going to do R1 plus R2 will go to R2. So I have 1, 3, 2, 1, and then 0, 4, 4, 2, and 0, 1, 1, 0. So now, well, obvious, 1/4 of R2, in other words, divide R2 by 4. So it is 1, 3, 2, 1, 0, 1, 1, 1/2, but this one is 0, 1, 1, 0. So that means, obviously, we have one more line, 1, 3, 2, 1, 0, 1, 1, 1/2. What I'm saying here is, negative R2 plus R3 go to R3. How about that? So 0, 0, 0, and then negative 1/2. Okay, so this guy is impossible. So what do you mean? It means C1 times 0 plus C2 times 0 plus C3 times 0 equal negative 1/2. That's impossible, right? So that is impossible. So no no solution. Okay, so no solution, or I'd say just impossible. Okay, no such a solution exists. Okay, so that is 59. You know what? Let's do one more. I like to do one that have a solution. How about let's try 61. 61. 61 is the coefficient matrix is negative 1, negative 1, 1, then 1, 0, 1, negative 3, negative 2, 1, and then the B is a 0, 3, negative 3. Okay. So now, well, that is negative 1, but I simply, negative R1 go to R1. Okay. So it is 1, 1, negative 1, 0. And then 1, 0, 1, 3. Negative 3, negative 2, 1, negative 3. So negative R1 plus R2 go to R2. So it is 1, 1, negative 1, 0. And then it's going to be 0. It's going to be negative 1. Wait a minute. So this is going to be positive 2. And then this is 3. Okay. And then let's do 3R1 plus R3 go to R3. How about that? So it is 0. That's 3. So it's going to be 1. It's going to be -3. So -3, -2. And then that's simply -3. Okay. So now I'm going to R2 plus R3 go to R3. So I get 1, 1, -1, 0. 0, -1, 2, 3. This one happens to be all 0. That means we're going to have infinite solution. Now, so I'm going to add, well, how about, R1 plus R2 go to R1. So what that means here is 1, 0, 1, and 3. And then negative R2 go to R2. 0, 1, -2, -3, and 0, 0, 0, 0. So we have reduced a row echelon form. So now what is meaning of this? Meaning of that is, C1 plus C3 equal 3. C2 minus 2C3 equal -3. So from here, so by the way, this is a free variable, meaning, this is position for C3. So this is C1 is 3 plus T. I'm going to say, C3 equal T. And then C2 equal -3 plus 2T, and C3 is T. Okay. So we have an infinite solution, infinite choices. Okay. Choices. And C1, C2, C3 is, let's see, 3, -3, 0, plus, and then T, it is 1, 2, and 1. Okay. So, I mean, one possible answer is when T equals 0. T equals 0 means 3 of the first vector, 3 of -1, 1, -3, plus minus 3 of the second vector, -1, 0, -2, will give me 0, 3, -3. Okay. I mean, if T equal 1, that will give me T equal 1, then it's going to be 4 of -1, 1, -3. And then T equal 1, then -1, 0, -2. And T equal 1 plus -1, 2, 0 will give me 0, 3, -3. We get infinite choices, okay?